Somewhere in the vastness of space might well lurk an unobserved asteroid, on course for a head-on collision with our planet. Its impact could be devastating for humankind. Should we not wish to experience the fate of dinosaurs, we best be prepared. This is also the view of ESA and NASA, as both agencies invest in locating these lonesome wanderers and seek to prepare a planetary defense strategy. As ESA's Hera spacecraft arrives at the ESTC test center in Nordvik, the Netherlands, humankind takes another step towards a safer future for our planet and its species. The test center at ESTC is the largest and best satellite testing facility in Europe and is equipped to simulate all aspects of spaceflight, from the force and noise of a rocket takeoff to the sustained vacuum and temperature extremes of deep space. This allows new spacecraft, such as Hera, to efficiently undergo the crucial tests needed to qualify for launch.
We need to make sure that the satellite works, which means the software, all the different pieces of software together work, and it does what it's supposed to be when it's going to be alone into space. And this entails not only doing the nominal operations, but even more importantly, to be able to react in case of failures, in case things go wrong, or things go differently from what we have planned.
At the facility, Hera will not only receive her metaphorical wings, proving her worthy of flight, but also its solar wings will be installed here. Finally, the spacecraft will be ready to meet its tight October 2024 launch window in order to make its appointment with the binary asteroid system Didos and Dimorphus. The Hera spacecraft is part of a larger program. Only a year ago, NASA's DART mission successfully impacted on Dimorphus, shifting the celestial body's orbit as planned. Now, Hera will survey the aftermath and the asteroid up close to help turn this grand experiment into a well-understood and potentially repeatable planetary defense technique.
One of the interesting aspects of Hera is that for the first time we bring two CubeSats with us. These are very small spacecraft, similarly to drones, that will go very close to the surface of the asteroid and gather complementary information to Hera. They will have ground-penetrating radars, they will have multispectral imagers. All of this, and as going closer, of course, they will take more risks. So the idea there is that we fly cheaper systems closer to the danger zone and keep Hera at a safe distance.
So, it is not only Hera that needs to be tested, but also the CubeSats it carries with it, and how the trio of spacecraft will work together in deep space.
Out of all these tests, which are typically performed on all the spacecraft that are launched into space, one of particular interest will be the one in the anechoic chamber, when we will assess the what so-called electromagnetic compatibility. In that framework, we will operate for the first time the CubeSat and the mother spacecraft communicating to each other via this inter-satellite link. This is one of the primes of the Hera mission in deep space.
Hera is a unique spacecraft, and compared to similar missions like Rosetta, Hera is about 10 times smaller and cheaper. An enormous achievement for the team. Soon, Hera will leave ESTC and be fully ready to take on the vastness of space and explore Dimorphus, teaching humankind about strategies how to defend itself against the asteroid that could end it all.